Okay, I'm back. And so what we have just derived is the formula for the force of gravity. Also notice that we should, to be perfectly precise, we should put a minus sign in front of this formula. And the reason for that is gravity always attracts. So if you got M1 and M2, they're never going to want to go away from each other. They're always going to be pulled towards each other. And so that's what the negative sign is in there for. So notice that I have compared gravity with electrostatics. So we got gravity in orange and then electrostatics in green. So in a previous lesson, we talked about electricity and said that if you had charge Q1 and charge Q2 separated by a distance r, then there would be a certain amount of force of either attraction if they had opposite charges, or repulsion if they had like charges. So if you had two positive charges, they would repel. If you had two negative charges, they would repel. And if you had a positive and a negative, they would be pulled together. So what I want you to see here is how similar and how dissimilar gravity is to electrostatics. Now, for your unit exam, don't worry about the electrostatics part, but you are going to take the final. So when you take the final in my class, yes, you are going to need to know about the formula for electrostatics. But for right now, you can ignore the electricity part and just concentrate on the gravity part, because that's today's lesson. Okay, but having said that, let's again look at the similarities. The cause of gravity is going to be mass, whereas the cause of the force of electricity is going to be electric charge. Notice that there's only one kind of mass, but there are two kinds of electric charge, positive and negative. Okay, you have conservation of mass. So that means that if this thing weighs 10 grams, and then I pull it apart, and then this weighs 9 grams, then this must have weighed 1 gram. So you can't create or destroy mass. Now, however, in our next lesson, we're going to be talking about nuclear stuff. And in nuclear reactions, we have to also take into account the amount of energy that is being released whenever something breaks up into two pieces. So just let's not worry about that yet. All right, now look at the formulas. So you see the two formulas are very similar to each other, but you should notice that they have a different constant of proportionality. So gravity has big G, whereas the force of electricity has the electrical constant, which is a fundamental constant of the universe. But the two formulas are very similar to each other. All right, so what kind of question could I ask you on the exam? Two objects get four times further away from each other. What happens to the force of gravity on them? So you're going to take the 4, substitute it in for the r, remember to square it. So 4 times 4 is 16. So you would say it's the force of gravity would be 1/16 as strong, or you could say 16 times weaker. And so either of those two answers would be acceptable on the exam. The other kind of question that I could ask you is, if I was to triple mass number 1, what would happen to the F? It would triple. Whatever I do to one side, I've got to do to the other side. What about if this one tripled and then this one doubled? So there's a 3 here, and then there's a 2 over here, so the answer would be 5, right? No. What do you need to do? There's no plus sign in between them. So 3 times 2 is going to be 6. Okay, so those are the kinds of questions that I think you should be able to answer on the exam. Okay, let's take a break. When we come back, we're going to talk about weightlessness, and then why are the astronauts inside of the International Space Station, why do they look like they're weightless?